So hello everyone, today we're going to work on our new lesson, system of equations or solving system of equations by graphing. What we are going to learn today is to write and solve system of equations by graphing to determine if the system has no solution, one solution, or infinite number of solutions. The new vocab that we're going to learn is what is the meaning of the word system of equations. We used to graph or solve an equation, but system of equations, what is the meaning of this? It means two equations, linear equations, written that we need to find a solution for them. Today we are going to work on solving this system of equations by graphing. So here in this example, it's asking you to solve the system. When I see the word system, this means that I'm going to have two different equations. So I have y equals negative 2x minus 3 and y equals 2x plus 5. And it's asking me to solve this by graphing. First of all, I'm going to graph each line on its own on the coordinate plane, but both of them will be graphed on the same coordinate plane. Okay, how did I graph the lines? I usually use the table of values, or even I can use the slope intercept, but for now, as we agreed in the session, we are going to work using table of values always in solving the system. Okay, so here it's y equals negative 2x minus 3. We will draw our regular table with x and then the equation and then the value of y and the ordered pair. And after drawing the table and finding the values of x and y, we will get this line. Okay, this one is going to be our line. And then we will do another graph where we will graph y equals 2x plus 5. Okay, and then we will check the intersection point. The intersection point of two lines, this is called the solution set of the system of equation. Okay, so here this intersect at a point. How can I get the coordinates of this point? I go from the point down to check its value on x coordinates. So this is going to be the x value is negative 2 and the y value is 1. So the solution set is negative 2 and 1. In order to check this, let's check. Y equals negative 2x minus 3. Let's substitute by negative 2 and 1. So y equals negative 2 times negative 2 minus 3, which is 4 minus 3. And this is going to give us 1, which is a right answer. Okay, in the other one, I'm going to substitute y by 1. 1 equals 2 times negative 2, which is negative 4 plus 5. It's also 1. Okay, so it's 1 in both ways. This is going to work, and our solution set is right. And that's it. As simple as this. Let's check another example. So here it's asking me to solve the system y equal 3x minus 2 and y equal x plus 1 by graphing. First of all, what am I going to do? Draw a table of values for each equation of them and then graph the two lines. I'm going to get this line for y equal 3x minus 2. It's written here on the screen. And the other one, it's y equal x plus 1. Okay, they have just one intersection point. Okay, what's this intersection point? Let's go down to check the x value. It's between 1 and 2, just in the middle. So this is going to be 1.5 on the x. And let's check its y coordinate. It's 2.5, which is between 2 and 3. So the solution set is 1.5 and 2.5. As simple as this. Let's check one more. Okay, so here in this example, we're not going to solve the equation or the system of equation. We're just going to write a system of equation that represents this situation. Okay, how can I do this? Let's read that we have a motorcycle, which is 2 wheels, and ATVs, which is 4 wheels in stock. This store has a total of 45 vehicles that together have 130 wheels. Okay, so first of all, we know that let's represent that the motorcycle is X and the ATVs is Y, okay? So X plus Y equals 45, okay? Again, here it's representing the motorcycles as Y and the ATVs as X. So I have Y plus X equals 45, okay? So the ATVs, which is X, is represented by, is four-wheeled, and the Y is two-wheeled. So I have 2Y plus 4X, which is the number of wheels in each one of them. So 2Y plus 4X equals 130. Okay, so the total number of wheels is 130. So 2y and 4x is 130. So now I have my system of equations, which is y plus x equals 45, and the other one is 2y plus 4x equals 130. Okay, and that's it. If it's asking me to solve this system of equation, we're going to graph it. But in this example, or in this one, it didn't ask me. So let's check the next one. So here we have the same example, but with the equations x plus y equals 45 and 2y plus 4x equals 130. And it's asking me to solve the system of equations and interpret the solution. What am I going to do? I'm going to write each equation in the slope-intercept form. I need to make sure that each equation written as y equals mx plus b. So here y equals negative x plus 45. And in this one, it's 2y equals negative 4x plus 130. So let's divide by 2. Y equals negative 2x plus 65. So here I have my two equations. Now I'm going to graph the two equations and check their intersection point. We're going to get a 20 and 25 ordered pair. So I have 20x and 25y, which is 20 ATVs and 25 motorcycle, and that's it. Now our example is over, and that's it. Easy. Now we can check if we want to check the answer, just to make sure that it's gonna work, and that's it. Easy, right? So good luck, guys. Here we have a system of equation. It's written in slope-intercept form that we are going to solve graphically. How can I do this? Again, I'm going to graph the two lines on the same coordinate plane. After graphing the two lines, I got two parallel lines. So they didn't intersect. What is the meaning of the word that they didn't intersect? That we don't have a solution set. Okay? So there is no solution for this system of equation. So when I got two parallel lines, I say there is no solution for this system of equations. Okay?